Hi, Bob Rasooli from Orange County. In this video, I'm going to review an important API 1110 question that you'll absolutely need for your API 1169 exam. You are preparing a hydrostatic test on a long buried pipeline that travels through different burial depths, different soil conditions, and areas with noticeably different thermal environments. The challenge is that temperature variations along such a pipeline can cause pressure fluctuations that may look like leaks or hide actual leaks unless you have the right measurement strategy. According to API RP 1110, what is the most accurate approach to ensuring that the pressure and temperature relationship is properly understood during the test so that test acceptance can be confidently evaluated? A. Rely on a single temperature recorder at the test head, assuming the temperature will equalize along the pipeline once the line is fully packed. B. Install multiple pressure sensors, but only one temperature sensor, because pressure readings carry more weight in leak assessments than temperature variations. C. Focus mainly on pressure equipment accuracy and reconstruct the temperature profile through soil temperature modeling rather than actual field measurement. D. Evaluate the test section and place temperature measurement points in multiple locations so that the actual thermal behavior of the pipeline is captured. Allow the test medium to stabilize before the test begins and include instrumentation uncertainty as part of the acceptance criteria evaluation. Why option A is wrong. Option A sounds convenient, and in a perfect world, it would be wonderful if one temperature point told us everything. But API RP 1110 does not operate on that assumption, and neither should anyone planning a real hydro test. According to the guidance in Clause 4.4, temperature along a long buried pipeline does not behave uniformly. Different burial depth, soil moisture levels, or even shade versus sun exposure can cause one section of pipe to cool while another warms. A single recorder at the test head simply cannot reflect what is happening throughout the segment. Temperature variations directly influence pressure behavior. So if you only measure temperature at one point, you're essentially guessing. That guesswork can lead to thinking there's a leak when there isn't, or missing a leak that actually exists. For that reason, depending on one temperature reading contradicts the very principles described in Clause 4.4 of API 1110. Why option B is wrong. Option B tries to sell the idea that pressure is king and temperature is just a minor factor. That's not at all what API RP 1110 teaches. Clause 5.8 explains that pressure variations during a test can come from temperature changes, not just leaks. In fact, temperature is one of the biggest influences on pressure stability. If you have great pressure data, but incomplete temperature data, then you still don't know if a pressure drop comes from a leak, a cooling trend in the ground, residual air dissolving into the water, or a combination of these. Limiting yourself to one temperature sensor undermines test interpretation. API RP 1110 expects temperature to be measured with the same seriousness as pressure, where long test segments and thermal variations are involved. So this option simply underestimates the role of temperature, which makes it inconsistent with the requirements and intent of Clause 4.4 and the acceptance considerations in Clause 5.8. Why option C is wrong. Option C leans into the idea that models can replace measurement. But API RP 1110 is very clear that temperature in long test sections has uncertainties that cannot be captured by a model alone. Clause 4.4 emphasizes that temperature in a pipeline is influenced by real-world factors that are almost impossible to predict with a model. Soil transitions, varying thermal conductivity, ground saturation, or a shade versus sun gradient. These are not theoretical. They're real daily conditions that affect pipeline temperature. Without real measurement points, the operator has no reliable way to interpret pressure changes. And since acceptance per clause 5.8 depends heavily on distinguishing actual leaks from temperature-induced pressure movement, relying on a model without field verification introduces unnecessary risk. So option C fails because it ignores the central idea in API RP 1110. Temperature is measured, not estimated. Why option D is correct? The option D is the only option that truly mirrors what API RP 1110 expects. Clause 4.4 tells us that temperature varies across a test section, and therefore multiple temperature measurement points are needed to characterize the true thermal behavior of the pipeline. This allows the operator to interpret pressure changes correctly, because now they know whether the pipeline is warming, cooling, or stabilizing in different locations. Clause 5.5 reinforces that the temperature of the test medium needs time to stabilize before the official test period begins. If the operator doesn't wait for stabilization, then early pressure shifts can be misread as leaks. Option D correctly includes this requirement. The final part of option D, considering instrumentation uncertainty, is exactly what clauses 4.4 and 5.8 imply. API RP 1110 acknowledges that both pressure and temperature devices have uncertainties, and those uncertainties must be accounted for when deciding whether the test meets acceptance criteria. Option D is the only answer that respects this full chain of logic. In short, option D is correct because it is the only approach that reflects the complete intent of API RP 1110. Measure temperature at multiple points, allow stabilization, understand the impact on pressure, and evaluate the test with full awareness of instrument accuracy. This is the only method that gives the operator confidence in whether the test truly passed or failed.